Great.
Well, welcome to the February 25th, 2025 session of Ham, 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 sorry, Tapper and HamSCI technical session. My name is Dave, KB0S, and this week I've been working on getting parts together for a demo at Dayton. Uh, in the Tapper booth. So planning to demo setting up simple setups on K9Q radio, something like I did last year. So that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I've been continuing to work on the HamSCI workshop planning with the HamSCI workshop committee, so that's coming along nicely. Um, I spoke with Tim Duffy, K3LR, and we have plans on installing a personal space weather station at K3LR this August 4th, 5th, 6th, and 7th. And so I can give more information about that in the open session. We've been having meetings with the um, group with uh, I've got a team at Scranton and with NJIT and David McGaw. We've been having meetings about our Antarctica planning and the personal space weather station. And so we had that meeting today, and that was very good. And we were very happy to see that the German Neumayer station has the RX 888 up and running. And I was wondering if I might be able to, if Rob, if you're in touch with, I think it's Michael Hartia that was doing
Yeah.
that, maybe we could have him talk with our team and we could hear about his experiences putting this in and his lessons learned and things like that. But it was wonderful to see that data. We also wanted to know if we could possibly show some of his data on our poster at HamSci about putting things in Antarctica. So we should probably get in touch with him. But it'd be nice to show what some Antarctic data might look like if we actually got more stations down there.
Yeah,
So
yeah. Well, that's that. It was exceptional data. I was
yes.
really surprised. Just that first day's data was a real surprise. He's traveling. He's in Cape Town right now on his way back to Germany. So
Okay.
it'll be probably next week before you could talk to him. But I'm sure he would be happy to have the data. I mean, I'll email him,
Yeah, please. And
and say that you'd like to put
yeah.
up some of the data from.
And we will be happy to acknowledge him or make him a
Oh,
co-author or whatever he wants. So, you know.
that
Oh,
I'm sure it would help him, with his funding and
hmm.
reports. I know that he'd ask Gwen. I think he asked Gwen or somebody for, some background on what we're doing with this and what the scientific value of the equipment that they put into service down there. So
Yeah, yeah. And I also do want to say that we have a group that's been meeting on Monday morning as well with Joe Huba and Kuldeep Pandey from NJIT and also Shibaji Chakraborty, who's someone he's now a research scientist down at Embry-Riddle. But he was in the Super Darn lab with me. He did his PhD, was doing it right when I was leaving Virginia Tech. But he's a really excellent scientist, and he's been making fantastic progress actually modeling the Doppler shift that the grapes are seeing in the Whisper Demon. So I've been able to um, send him my data from the Whisper Demon Grape I have running here from the Eclipse, and he's been using Joe Huba's Sammy 3 outputs, and he actually has some really wonderful plots showing the modeling of this data. And he sent me some figures earlier today, so if anyone wanted to see that later in the session, I'll be happy to show it. So yeah,
Sounds
back
like
to
a
that.
good idea. Next on the list, I don't have my gallery up. Here we go. Is Dave, KD0EAG. Go ahead, Dave.
Hello. I'm here as usual, not doing a special lot of exciting stuff to report, but just trying to accumulate some equipment for placement up in North Missouri at a farm for a future site. Perhaps other than that, not much to tell about. Back to you.
Oh, okay. Next on the list is David McGaw, N1HAC. Go ahead, David.
Good evening, everyone. As Nathaniel said, we've had a number of meetings already today. Antarctica being an important one, and of course, the eclipse, looking at the eclipse data. And let's see, most immediate here, I do have a test bed that I've set up here. We've been talking about improving the low frequency performance of the RX-888. So I took off the transformer that was on there and have a socket on there, and I can swap in various transformers, see if we can improve that. We should be able to. I'm sure it was not designed to go below like a megahertz, really, but I'm sure there are other limiting components. I've already removed the inductor for bias T. And by the way, if somebody were to want to power preamp down to low frequencies, we can just change the bias T components. And then, well, I guess one big thing is I was able to get a hold of the chief engineer at WWV, and our modulation is back. So it turns out they did have an equipment failure there. They were able to swap it out or fix it or
I
whatever.
was wondering about that.
We have that back. Yeah, it was a time code generator that failed that was driving the 8 minute past the hour. The interesting thing is that it was doubling the 4 minute past the hour. Maybe not everybody had heard that, but they had an extended, they have an extended announcement at 4 past, and then the actual modulation at 8. It was just duplicating that. But mystery solved, and we're back in business for anyone who's using that actively or passively. I mean, I enjoy just hearing it. It lets me know, oh, it's 8
Should be
minutes past the
transmitting
hour.
right now.
Yeah,
Yep.
you're right. It is. So, and then looking forward to the workshop, which is rapidly coming up. So back to Nat.
Okay. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Not a whole lot going on here. Trying to get my tanks in order and some miscellaneous stuff done. Not much on ham radio yet.
Okay. That's it.
That's it.
So next on the list is Clint, KA7OEI. Go ahead, Clint.
Nothing too exciting in the moment. I'm just trying to get the multiple channels of a CW skimmer up. I think I mentioned earlier that we going to a virtualized server and trying to figure out how to best get the extremely archaic Windows applications to play nice when there's more than one or two, a couple of them. Turns out, depending on things, you can either run between 8 and 10 of them at a given time before Windows no longer schedules them for processing time. And so the obvious solution is to have instances. Well, it turns out that, well, and also the problem seems to be that the code was hard written. It was hard coded to always use core 0, no matter how many cores you actually have. So we think we figured out a way around that in our virtual configuration. But it would be really, really nice if something newer than the 2013 update of the skimmer was around that actually worked worth a darn. There's other things newer, but none of them seem to work quite as well. So anyway, that's about it.
Well, sounds like you got plenty to work on. Next on the list is Dave, W6OQ. Go ahead, Dave.
Good evening, everyone. I'm here.
I'm listening, trying to pick up on what I might be useful with. Um, Rob did send me a field probe that came today, so I'll be getting to that later this week to sort of see how it works and how it might be useful. That's about it. Thanks.
Okay. Next on the list is Dave Julian, WB9YIG. Go ahead, Dave.
Oh, good evening, folks. Couple little things. Got a little bit of a event. My Grape One clicked over 1 year online as of yesterday. So it went there. And also Dave New and N8SBE. I worked you on the EDM exercise a few days ago. So
Yeah, I thought that call was familiar.
yeah. But other than that, back to that. That's all I got.
Okay. Next on the list is Dave New, N8SBE. I think I got it this time.
Hey. Yeah, well, I'm the usual fly on the wall here. There's always something interesting here for me to be interested in, and I end up getting, down rabbit holes over here. So the most recent thing was bringing up another hotspot, a DMR hotspot on a Raspberry Pi with a very old DV4 Mini USB modem for a 70 centimeter modem. So it's been a while. But anyway, that's what's going on around here. Oh, and we hit 50 degrees today, so we're having a heat wave in Ann Arbor.
We're up in that neighborhood too, so sounds good. Next on the list, let's see, is Elmer. Go ahead, Elmer.
Hi. Short. I added another RX888 to the system and got up another SAS antenna, which are at the same height on top of the house. They're about 30 feet in the sky, running 2 meters. In other words, the length of the antenna is only 2 meters at this point. We'll probably make it a little bit longer. I am plagued with broadcasts from New York City. I live on the water, and I can develop enough voltage probably to light an LED. But anyway, that's up and running. I'm also printing parts to test Cat5 positioning along with the wire to see the effects of shadowing, if you will, of the Cat5 and how far away it's going to be. So I call that the tomato project because I'm using tomato sticks that look like this. So I print the plastic and it has a hole and there's caps that go on the end to hold the systems, and they're adjustable so I can use them from different projects. And Rob's doing really well with his code because I'm looking at the contacts on the three of them together and they're fighting for first place. That's it.
Very good. Next on the list is Gary, AF8A. Go ahead.
Yeah, good evening, everyone. I've been spending most of the week trying to keep up with the agenda for the workshop, making sure all the abstracts and things are online. I think I'll put that in the chat in a minute if anybody hasn't seen it. So just looking forward to the workshop. Elmer, good to see you. Hopefully you got all the information you need today and we're ready to do your demo. I'm excited to see one of these RX888s in person and talk to someone who's got some experience putting one together. So looking forward to that. Back to you, Dave.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been kind of occupied this week. Unfortunately, I did not get a chance to engage in a lot of VLF activities, but I provided some more guidance to Michael regarding setting up a VLF system at his location. So I figured the best way to start would be to start with building the preamp, and that is So that is the impedance matching and gain stage for the probe antenna element. And it provides a signal output that can be driven over a long Cat5 and is much lower impedance around the audio range of impedance around 600 ohms. And that also includes an isolated DC to DC converter and audio isolation transformer. To start building the preamp is probably the most important part here, because once we get that built, then we could get the antenna assembled, and then we could actually test it. We could actually use it as a makeshift field probe to try to scout out the best location. That's I believe that's the best place to start. And when Michael is ready, I'll be glad to help him. I'm also in the process of doing doing a board layout for the preamp. I just have to figure out KiCad. I've been using Express PCB for many years, but the problem is that if I use Express PCB, then I create all the footprints. If I ever wanted to, if I ever wanted the Gerber files, I would have to pay for them. And if I ever wanted to make a change, then I can make a change to the Express PCB file, but then I have to pay for the Gerber files again. So even though Express PCB is much easier to use, or should I say easier to figure out, it's more beneficial to use something like GEDA or KiCad to actually do the layout. But the problem is that I have to pick one because I don't believe the footprints are interchangeable. But the main thing is that I have to make the footprints. There's a lot of like non-standard parts like screw terminals and the isolated DC to DC converter, the audio isolation transformer. Those are the non-standard footprints. There may be some available, but more than likely not. So I would have to make those footprints myself. But once the footprints are made, then the layout is actually pretty easy. But I just have to actually sit down with KiCad and figure out how to use it. Because I have never used it before. I've tried it a couple times. It wasn't as intuitive as Express PCB. So that's what I have to do. Because what I would like to do is I would like to get as quick as I could an actual PCB for this preamp, and that will speed things up quite a bit. But in the meantime, I'm currently working on that. That's all I have. Back to the net.
Okay. Next on the list is Michael Howen, AC0G. Go ahead, Michael.
Hey, Dave. Good evening, everybody. I've been came down with a little bit of a cold yesterday, which is annoying, but it's not hurting me too bad, thankfully. Working a lot on the antenna business, working with some Whisper Demon support things as well, including some documentation. Any of you who look at your code should see a docs directory in Whisper Demon, whether it's 3.2.3 or 3.3.1, which has those files. You can browse it with your HTML browser. It's also up on the web at whisperdemon.readthedocs.io, I think, something like that. Anyway, It's not a project I can in any manner, shape, or form do by myself. So if anybody has some things that they'd like to contribute or errors that they identify, that would be most welcome. Yeah, but today Elmer and I and Glenn and Rob spent several hours going over some antenna things related to how we're interpreting the findings from the spectrum and some features of the single antenna system and so on and so forth. It was kind of educational. I don't know how much progress we made, but we're learning along the way. Hopefully we're learning faster than we're forgetting. Back to net.
Very good. Next on the list is Paul Elliott. Go ahead, Paul.
Yeah, hi everybody. Jonathan KiCad, I highly recommend it. It's once you get used to making your own footprints, it's really not that hard. I pretty much make all my footprints. Yeah, me, I've been working on adding some features to Whisper Sond. One of them requested for the Newmeyer Antarctica operation. So that's just a simple matter of software. I've been playing with filters and filter responses, and Glenn and I kind of collaborated on a 60 megahertz low pass filter that he did a prototype of, got some samples back pretty quickly. I've been looking at, improving my modeling. The capacitors, generally the caps are way, way better than the inductors, so you can kind of use ideal capacitors. But if they do go series resonant, and I have tweaked my models so they actually sort of kind of match what I'm measuring, up in the hundreds of megahertz to a couple gigahertz range. So that's been enlightening. Last couple days, really, my mom just turned 100 years old yesterday. So, yay! I hope there's something in those genes, that I got.
Yes.
But we'll see. She's doing okay for a woman who's 100 years old.
Oh,
Cut
Paul,
it
That's
a little bit
awesome.
of my engineering time.
Congratulations.
Yeah, well, congratulations to my mom.
Yeah,
I'll pass that along. Thank you.
that's wonderful.
Yeah. Um, yeah, not much else. I'm expecting in about a week and a half, I will have some new preamps, the 60 megahertz, ones that'll go up to 6 meters, the low pass filter with a real kick-ass 88 to 108 megahertz rejection notch, seeing about 70 to 80 dB of attenuation there, which is, way more than probably necessary or even useful, but it's fun to see the results. So we'll see how that goes. See if the real world performance matches my modeling. Looking forward to that. Other than that, probably not much. So back to net.
Okay. Next on the list, we'll go to Scott Newell in 5TNL.
Hey guys, heard that WWV was doing the HamSCI modulation test, so thanks for that. Other than that, nothing to report, so back to net.
Okay. And then next on the list is Tom Yarnish. Go ahead, Tom. Are you there?
He's monitoring only. He's
I am here. I'm busy, distracted, but wanted to say hello to everybody. It's raining here in Northern California, and not much else is happening. So back to net.
Well, very good. Glad to hear you, Tom. So next on the list, we have Rob Robinette. Go ahead, Rob.
Okay, let's see. You guys see me and hear me?
Yes.
Okay, well, you've heard about a number of activities. I've worked with Paul and Michael Harche to get the DP0 site up. And it is, we now are making, you saw the WWV recordings, which I hopefully will inspire people. I was really surprised, I confess, that what surprised me was that how stable the 25 megahertz carrier was when the bands are open. There isn't a whole lot of Doppler shift. It's really amazing. There must not be many skips in that path when it's open. So I've been working we on Whisper Demon. We're with Michael's help. We've been well into beta testing. What I hope will be the basis for the deployment, the Daisy 2 deployment software. Um, the issue that's I think come up was Phil Erickson brought up, which was sample accuracy. To what are we able to verify that there isn't even a phase shift, a single sample lost in the whole digital signal processing chain? And Scott did some investigations that suggest there's certain, I think I've said this before, there's certain change in the steps in the transmission chain where it's really not possible to monitor loss of a single sample, specifically on the USB transfers. Those are done by DMA engines, and there's no it'd have to be a pretty gross error in the USB transmission for the software to detect it. So, but the tests that Scott ran went all the way to WAV files, and I think he ran them for days. Scott should report more on this, but my understanding from this was that he could not identify that there was any loss of data. I mean, not a single sample loss in the USB transfers, nor were there a sample losses on the IP transmissions. And as far as I can tell, there are no samples lost by K9Q radio in its processing. So that's, but I don't know that we've done a thorough examination of these. Doing this, validating this, is kind of beyond the boundaries of my understanding. So the way to validate this, ideally, you do this continuously, right? When it's in the field, we'll know if there's any loss of data or corruption of the data streams. But as far as I can tell, even on the Orange Pi, in fact, the Orange Pi happens to be one of the most reliable platforms that I'm running on now. Even there, that there's just it seems to run for days without any interruptions, except for me putting new software on it. So that's kind of my goal now, is validation and reliability and deployability and supportability of it. And I think we're not at the end of that process, but thanks to Scott and to Michael and to others, I think we do have a platform. We basically still have to make a choice of whether we want to do this on the B-Link or on an Orange Pi, and there are kind of arguments for both. I don't know if we want to if we have a deadline for making that decision, but I'm hoping we can do that, make a decision and figure out how we're going to make these Daisy 2s. We need 20 of them, and we want them to be the same and reproducible and supportable. So I'm hoping that we put together some kind of a meeting where we talk about all the deployment issues. So that's there's plenty more as usual I can talk about. If you'll see me in the background, I'm packing to move. We're going to move across the hill about 10 miles from here next week. So it won't really have any effect on any of you or even me. I'll have still the same access I have right now to KFS. So it just it's a good 10 degrees warmer on the other side of the hill and closer to all of our doctors and things like that. No stairs in this new house, so it's uh, no, reduce the risk of falling, which we experienced. So anyway,
Can be
that's
a
my story.
can be a shorter drive or a longer drive to KFS, Rob.
Oh, it'll be a longer drive.
Oh, that's too
Yes,
bad.
but it's a half hour. It's an easy half hour drive, and it doesn't make the trip out to KPH any longer. Oh, I should make. I don't know if I want to make this is an opportunity. There is going to be the chief engineer of the HARP um, array up there in Alaska is going to be visiting KPH up in north of San Francisco for a visit on Saturday, March 29th, I think it's a recollection. If I don't know if that anyone in this group was apart from Paul, I think there's nobody nearby, but if anybody is interested in this, I can forward you the information. But and if you want to fly in, if there's fly in, I'll come pick you up at the airport and drive you out there. It'd be easy for me right on my way out there. But I'm looking forward to that. It seems to me that there ought to be ways for us to exploit and extend the capabilities of the DAISY 2 network to record and help them analyze HARP transmissions. We we are, we have a platform now. It's hardly restricted to Whisper and to WWV. We could add dozens, if not hundreds, of more receive channels and recording um, channels if there are other researchers that are be interested in this. So anyway, if you're interested if you're going to be here in the Bay Area, end of March, I'd be happy to take you out and you can meet him. So
That's really great, Rob. Actually, about a week, 2 weeks ago,
yeah.
I had a telecon with Steve Serwin and Diego Sanchez and Paul Bernhard. So Paul Bernhard is KF4FOR. He's the chief scientist for HARP, and so
Uh-huh.
we were starting to talk about ways that HamSCI could collaborate with HARP as well. So
Uh-huh.
Steve Serwin's been starting to think about it. We did, talk to. I did show Paul Bernhard the RX 888 and
Yeah.
talk to him about that. So hopefully he's starting to think about that a little bit. And I guess when you say the chief engineer, you're probably talking about Steve Floyd.
Maybe I should pull up the email. I didn't remember his name, to be honest.
Yes, should be Steve Floyd.
Yeah.
Yeah. So yeah, I think that'll be really good. And I've been thinking about trying to possibly have the harp people be invited speakers at the HamSci workshop in the next year or two. So I think good luck with that visit. I think that'll be really great.
Well,
Yeah, it is.
he'll
It
have,
is Steve. It is Steve Floyd who will be there.
Mm-hmm.
yeah.
Yeah,
Yeah.
I don't know if I can make it, but boy, I'd sure like to. So we'll see.
Please tell him I said hello.
I will. I will. Well, the anyway, if I think we're meeting at the transmit facility rather than the receive site where the Kiwis and the 888s are. So I don't know if he's planning to go out there do a complete tour. But if he does, then I can show him exactly, show him the hardware. Although it's not, I can, I'll bring it along just to show him an example. Even if we don't go out there, I can show him what physically it looks like. I think mostly the point being, it's really small, low power, inexpensive, and yet it's scientific grade. We think, right? Do we? I think we're doing real science here.
Yeah.
So.
I think so.
Yes. Well, I believe I've called on everybody. Anybody not been called on?
I'm here.
Oh, Phil. Sorry, Phil.
That's all right. Let's see. Lots of miscellaneous work in the last week or two, little bug fixes and such. Clayton Smith has really been a help. We got to get him pulled into this organization. He's been a real help. VE3 IRR, somewhere near Detroit, Southern Ontario. Anyway, he has HD radio decoder that I'm now able to feed with KNIQ radio. We found a couple little little things there. I'm finding that the more different applications you get for a piece of software, the more likely they are to find all these little bugs that would never show up in a million years in some other application because you don't use it in the same way. I've also been trying to make lots of little performance enhancements, and it's very frustrating on modern CPUs because you find something you think is really going to help things run faster, and it makes absolutely no difference at all. Stuff like huge pages, and let's see, huge pages I tried, and it actually made things worse. I've been trying to do dropping caches for blocks of memory that I know I'm not going to use, and that either has no effect or makes things slightly worse, stuff like that. But you have to try these things to find out if they're going to work. But the only thing I reliably find that makes a program run fast, a DSP program run faster, is to reduce sample rates.
Yeah.
That's pretty much guaranteed. Other than that, nothing seems to really work. Perform
You've
what you always expect it will.
you've been I would say processor affinity don't
Yeah,
is
that one. Yeah, that one is.
that works incredibly well.
I want
And
to put that. I want to put processor affinity in because you've had such good luck with it. I want to put it in, but I want to do it in a good general way that won't bite
it's
people. Or just not
it's
figure it right.
it's really hard to do generally. The cache structures of these CPUs vary significantly, and you really need to understand the structure of the cache before you start assigning
Well, the
tasks to
first
CPUs.
thing I think it might be fairly safe to do is as an option. They'll make it default. Make as an option. Find out what core you're running on, and then ask to stay on that one. That seems fairly safe. The other thing I want to do is find out in hyper-threaded machines, which are most Intel machines these days, Intel or AMD machines, find out which are the sibling processors on the same core, and then say, okay, I could run either one of those because they share caches.
Well, especially if you look through, if you look through it, you can find siblings even if they're not hyper-threaded, but they share the level 2, level 1. Well, usually
Well, that's usually what that means.
Level 2. If they share the level 2, that can help because there are some of them that don't have a level 2 shared per. Where each core, hyper-threaded core, doesn't have its same level 2. The Intels are really bad that way. They have cores that have no level 2 on them.
Often, some of them,
it's really bizarre. So
yeah.
So it's really so far I'm ready to put in a table where I put in the CPU version and where to allocate tasks and just do it that way because I haven't figured out algorithmically how to do that.
Well, you can get all the information you want about a CPU from the CPU ID instruction. I mean,
yes,
you can do that. You can do that stuff.
It's all there. Just trying to figure out how to take that information and algorithmically figure out how to assign different processes. I mean,
a lot of my ideas I got from ChatGPT and turned out to not go anywhere. ChatGPT would let me think, oh, this has got to really help, and I try it, and then it says, oh no, it wouldn't work. It always agrees with everything you say, whether you want it to or not.
Well, it led me. I mean, I learned about how to manipulate. It gave me a hint, which was a lot more. I didn't even know about things like the task set command. I didn't know it existed.
Yeah.
And so I didn't know that you could assign CPUs in the service files. So you can do CPU affinity there.
Mm-hmm.
But so I learned but after that, no, it's not helpful after that.
Yeah, it's good for giving you hints. And sometimes hints can be very valuable, but everything has to be tested.
It's given me whole bash routines that are perfectly functional. So
once you test them.
Oh, well, oh no, you have to go and edit them out and but yeah.
One of the founders of Qualcomm, WT6G, Klein Gilhousen's a silent key now, but he had a wonderful saying that I quoted all the time, I repeated all the time at work, which is, if you haven't tested it, it doesn't work.
Yeah. No,
One of the most profound things I've ever heard anybody in engineering say.
Yeah.
Yeah, exactly.
I could believe that.
Yeah, well, that's exactly what I'm doing right now. I've recently just I was never certain if I've ever missing whisper cycles. You know, you run these things and the systems become so complex. It's so easy to, oh, why does this have fewer spots? Oh, there was a transmission error or something, and it dropped a whole cycle and just
Yeah.
didn't pick anything. You know, that's the kind of stuff that I'm doing now. Is to
God, I mean, I think the last computer where I can make any kind of claim that I understood everything that was going on inside of it was my Z80 in about 1970. Really,
Yeah.
I mean, because I wrote all that software, right? Beyond that point, no, never since.
Yeah. Yeah, 68,000 for me.
Yeah.
I
Same
I
time
could
frame. Yeah, same
I could count cycles for the CPU instructions. I knew what registers had
Yeah.
what and the cost for every register movement and memory access.
And I'm not sure how you really ought to teach computer science to students today because you and I grew up with computers, right? When we started learning, they were easy to learn. I mean, how do you
Right.
do it now, right?
I think they start out with STM32F4 boards because you can get them for
you could do
like
that.
$10
Okay.
off of Amazon.
Yeah,
Yeah.
you could do that. You could do that. Yeah, we start out with a really simple machine, comparable, although still far beyond what we had. But yeah.
Yeah. My know-it-all processor was a Motorola 6802.
Okay. About
I
the
used
same,
that
about the same
put
era.
together a repeater with, including a CWID and everything, all done in software.
Yeah.
So how many people wrote an octal?
How about split octal?
I did briefly when I
digital
programmed
group
the
systems.
PDP-11. I liked the PDP-11 architecture, but I didn't like octal.
Yeah, digital group systems.
I had a 23, PDP-11 23 in my house with two RLO 2-packs on it. It cost me $800 a month for electric. I had to shut it off.
Oh, geez.
Wow.
Yeah.
$100 a month for electric? I knew what 1123 was. It wasn't that big.
So how many people had a digital group system by Robert Suding, Dr. Robert Suding, W0LMD? They ran in split octal. You programmed them in split octal.
Split octal, yeah.
And you get you can get different CPU cards for it. So they had a 6502 and a 6800 and a Z80 and an 8080 CPU card that you could plug in. So
okay,
take your choice.
Yeah.
And the audio cassette interface ran at 1100 baud and was wide shift ready.
Wow.
Now, how many people can say they designed a processor?
I did. Well, part of one, and we had a design project in college.
Yep. Yeah, we designed a 12-bit processor. Yeah.
Yeah, the heart of the synclavier was a processor built out of TTL, and I designed a number of versions of it.
Yep.
If anyone's interested, I have Shibaji's slides showing the modeling of the Doppler shift from the eclipse observed with the Whisper Demon grapes.
Go ahead and show it.
Okay.
We're interested. I'm interested.
Yeah.
So yeah, this is going back to I think Rob's point where he thinks we're doing science, at least he hopes so. So I believe that yes, we are in fact doing science. So these slides I'm going to show you are from Shibaji Chakraborty. So he's a research scientist at Embry-Riddle, and he has been working on this data. So here's the eclipse data received with a Whisper Demon grape at my house, right where I'm sitting right now. And here's the eclipse S-curve. And from his work with SuperDarn, he modeled HF Doppler shift of solar flares that were observed with the SuperDarn radars. And so he has some papers published where he'd use a solar flare model or something called FISM, and then that would go into some other whole atmosphere community climate model with thermosphere and ionosphere extension called WACA-MEX, and that would give you electron densities over here, and then those electron densities could be fed into FARLAP, and using those things, that could be fed into a Doppler shift model that was developed by a scientist named Kikuchi in 1986. So he tied all that stuff together, and he's published a number of papers using SuperDarn data in that particular model. So he took a look at our data, and he said, you know what, I bet we can basically do the same thing, adapt this framework for the HF Doppler shift that the grapes and the Whisper Demon grapes are getting. So he just replaced the solar flare model with an eclipse mask, and here for the ionosphere we're using the Eclipse SAMI 3, which we got from Joe Huba, and here's just this little cartoon of how the Kikuchi Doppler model works. And then, here, WWV, here's my station in Pennsylvania. There's the eclipse. And here's where he's running far lap for this particular set. And I don't think you can see the Doppler shift here, but he's showing that modeling um he's modeling takeoff angles between 5 to 60 degrees with 0.5 degree steps. And here's my station over here, almost at 2,500 kilometers away from WWV. And let's see, this morning he showed it. He had a movie of this. And so here's the actual model. So
Oh,
each
you
of
may be
these,
sharing your screen, Daniel.
I do. I think I'm sharing my screen.
Are
I'm
you?
seeing it.
Yeah,
I'm
I'm seeing
seeing
it.
it. I'm seeing it.
Oh,
Yep. It's
Yeah.
there. Keep going.
Okay. So these are the results. This is a model Doppler shift using SAMI 3 and FARLAP modeling my data. And so this is for 10 megahertz simulation with elevation angles less than 45 degrees. And you can see that each blue dot represents a Doppler shift from one of these rays that reaches our location. And it's in a 5 minute, the modeling was done in 5 minute increments, which is why you see that. And here you see the negative portion of the Doppler shift at the beginning. There's the positive at the end. And here's how it looks if you line it up on top of the data. And so I think he does a really good job capturing the basic shape of what the observations are.
That's the famous S curve we've talked about over and over again, huh?
It is. And there you can see those blue dots are lining up very nicely.
Yeah.
So,
Wow.
Yeah.
That's great.
And so there's certainly, what's that? Go ahead.
This is Dave Larson.
Yeah.
Is there a kind of a legacy in step to step in this model?
What do you mean a legacy?
It seems like once the background data starts changing, it takes a little bit of a time for the model to catch up.
So you're saying that there's a lag between what the background is doing, and then you see it later in the model.
5 minute steps.
Yeah, I'm not sure yet. I think so we have the basic shape down, but yeah, understanding that lag, why the data is going faster than the model,
Well, a lot of times you put in terms that discourage following the data too much, and just to get rid of noise. But it seems like whatever that parameter is, it's pretty strong in this model.
Yeah, no, I don't think, my understanding is that the data wasn't used in the model at all.
Okay.
So the model came strictly from, what was used is knowledge of where the transmitter was and where the receiver was. And then aside from that, the model is the SAMI 3 model, which
Okay.
is entirely a prediction. It's all physics based, doesn't have any input data, so it's not
Okay.
empirical, not data assimilative, and then that goes into FARLAP. So these values don't take in any data at all.
Okay.
And so he's just modeling basically the geometry or the path that we have, and
Okay.
just with that, so no data assimilation. This is entirely physics based. It's lining up really nicely.
Yes, it is.
Although if you shifted it to the left just a little bit, it'd line up even better.
Well, I think that's what Dave is saying.
Yeah.
Yeah. So this is where this is where we are this morning. And Shibaji, basically went from having, not from barely working on the grape data in December to having this now.
Yes.
I think it's really, really fantastic.
Yeah.
So yeah, where we go next, how we, Shibaji is noting how there's like, it seems like there's a couple of different modes there. You're just trying to look at that a little bit. Um, Another thing that he's doing is he has a way in this model of separating out whether the refraction is dominated from change in height or change in refractive index. So he's working on that as well. This model helps him to pull that out.
Mhm.
So this is.
Is he familiar with Glenn's work? He's going to give a presentation on at the HamSCI on the observations for and some observations about multiple paths.
On Gwen's work?
Yeah.
I'm not sure if he is, but I did tell him this morning that he should go talk to Gwen.
He should. I think he should. Yeah.
And in fact, one of the things Shibaji wanted to do was Shibaji asked me, were there any good receivers over in Europe? And I said, well, you should really go talk to Gwen Griffiths. So Gwen should be getting a message very soon.
Good. Yeah, we have several superb sites in Europe. So
yes, so I can't speak to all the details of everything Shibaji is doing, but I did want to show this and make the point that yes, people are really using this data, and people are scientists are actually working on modeling it and doing real science with this. So I think this is very, very, very encouraging.
yes, that is great. It's great. Well, you've kind of that stimulated the thought that you should really talk to John Melkor, who runs the EA8 BFK receiver, which is out on the Canary Islands, and it is it's the best QTH in the world for he gets one hop into Europe and one or two hops into the most of continental U.S. So he receives everything. And we were looking at some very surprising whisper spots coming from DP0 on 10 meters. I mean, there are on many evening gray line times, you'll get you'll get up to +2 dBn SNRs on 10 meters with almost zero spreading from DP0, 13,000 kilometer path, and almost no spreading. So it looks like that there must be a fairly consistent, maybe this is well known in the community, but there appears to be a transequatorial, like a waveguide that appears up on 10 meters. It would be interesting to go up to 6 meters and see what happens, because it's but it's surprising that 10 meters would be actually the best performing frequency band for transmissions from the Antarctic.
Yeah.
But you saw that in the 25 megahertz WWV spectrograph I emailed about. I mean, there was almost no, for hours, there was almost no spectral spreading. How does that happen? I mean, on that, that's another 13,000 kilometer path.
Fewer waveguide modes?
It seems to me it has to be some kind of waveguide mode. Maybe this is well known. I don't know.
Fewer modes, fewer different ways you can go. Especially if the critical angle is fairly low, right? I mean, there's only like one way it could go.
Well, yeah, I think that there are propagation mechanisms where the waves never hit the ground; they just refract.
That too.
repeatedly.
Oh,
yeah,
okay.
Yeah, I was
So,
gonna say that's how I get WWVH without hearing WWV at the same time.
yeah, yeah,
That that happens a lot. That's just skip zone.
So the other thing I
But
wanted
the
to
point being that it's not doing a double skip, or I'd be hearing WWV. It's
yeah.
doing a
Right.
it's
Yeah.
ducting.
So the other thing that I wanted to say that we're planning is installing a PSWS system out at K3LR. And so Gary and I talked with him this past Tuesday. And so for a quick review, K3LR is located in western Pennsylvania. So here's Ohio over here. Here's Pennsylvania. There's the border. There's Route 80. And so if you zoom in, you can see over here is his main operating barn. Over here are the large towers with the main transmitters. He's got
Oh,
some fields of
I've driven by that and seen that huge array.
yes,
That is it's an incredible system.
it is absolutely incredible. And then if you go to his QRZ page, he has some nice flyovers. So we were watching I think we're watching, he's got all sorts of different, yeah, you can see over here just absolutely incredible system.
Any ham who buys his neighbor's properties and the
Yeah.
properties across the road to expand his station, you know it's serious.
Yes. Yeah, he's quite serious.
I know.
So
I wonder what the non-hand neighbors think.
well, I think by the time he's done, he won't have any.
So what
Probably think he's CIA or something.
yeah, how does I mean these high power transmitters will deafen receivers. So I mean,
Yes.
how often are these things operated, and is
So-
there a
Well,
Well,
every contest weekend,
Yes.
and sometimes
But
during the middle of the week. Yeah.
Is it possible that there's a site somewhere near there, but not exactly this site?
so what we were talking about, so the proposal right now as of Tuesday was that here's his barn, here's the big towers. He owns this house across the street. And so to put the receiver, the PSWS receive antennas over here.
That's a couple 100 feet at most, isn't it?
Right. Keep in mind also that he's got a CW skimmer reverse beacon node running that runs quite successfully. So
Yeah,
it's not like he hasn't done receiving at this site before.
yeah. Well, it'd be worth a try.
Well, I think that's the thing, a couple of thoughts here. So if we can I do think that if we want this system to be more widely adopted by hams, we have to have, ways of making it work in locations that are fairly in close proximity to, kilowatt amplifiers, if possible.
Yeah.
And one thing here is that these proposed antennas are probably going to be at a much lower height than any of the stuff he's got on his towers. And the takeoff angle coming off those towers is going to be anywhere from 20 to 30 degrees above the horizon, is where the major lobes are.
Mm-hmm.
So
So
you might stand a chance.
and Tim does have experience with CW skimmers,
Yeah.
and if there's anyone out there that probably has a chance of helping to mitigate some of the interference from this sort of stuff on a receive system, it's probably Tim.
Yeah.
And he said that he would give us an entire bedroom in this house that would just
Wow.
hold the PSWS system. That would be our room.
Hmm.
And he'd have it all trenched out for us and the coax laid. And we could send a team out there August 4th, 5th, 6th, and 7th to do the installation.
Wow.
Yeah.
So and he's basically rolling out the red carpet for us. He said that, he's got the team of people who do the trenching. He has an IT team that can make any ports we want open and available to us. He has he also wants to bring in he's involved in the local college a little bit, so he'd like to be able to invite some of those students over to have a barbecue with us and invite like local TV and media to come cover the installation of this thing.
Oh, wow.
So I mean, and it's kind of a big deal. So I think it is a big challenge putting the system in a place like this, but I think it also is a lot of opportunity to, try to figure out how to make this coexist and work. And I think, Tim would be very helpful in helping us try to figure out some of the engineering challenges.
I mean, the absolute worst case is you have to turn off the receivers on CQ Worldwide, AWR LDX, IARU, or so on and so forth.
Mhm.
But if the other 360 days a year you can figure out how to deal with most of the interference and all that sort of stuff, it's a huge win.
Yeah.
Yeah.
Or I don't know if I know with some of the active antennas that they sell in DX Engineering, they have recommendations for doing transmit receive sequencing. So you basically put a TR switch in there and you turn off the antennas. And if he has a CW skimmer, running a similar system, maybe he does have it set up so that you can do QSK and maybe there's a way of getting that signal over here. I don't know. I think.
I don't think that's a big problem actually. I mean,
Yeah.
I mean the RX 888, one of its strengths is that it
Mhm.
has a variable gain amplifier.
Mhm.
So it's pretty much impossible to overload the 888 for more than the 10 seconds it takes Phil uh, to update the gain on the VGA. I mean
Mhm.
uh, I mean we've got uh, I I forget who it is. Oh, Elmer. Elmer's got 50 kilowatt stations that are generating a volt on his dipole feed point. So
Mhm.
we can the AAA can deal with it. I mean, at that point you're deafened because you can't hear for the duration of the transmission until the AGC recovers. You don't hear much except the transmitter, but no, I think the system as it's set up, it'd be fine. To me, it would be interesting to also be able to put triple eights on their heavy duty antennas, and when they're not transmitting, listen on those and compare the performance of, these monster high,
Mhm.
beams against our reference antenna or whatever antenna you want to put up there.
Well, I imagine that if we're, asked to do that for a couple of days, Tim would probably find a few days that we could do that. So
Yeah.
it's certainly a
So,
possibility.
Nathaniel, I have one other question for you related not specifically to this site, but um, do you still have contacts at Svalbard? And what is the possibility of putting one of our receivers up there?
I think it's a very good possibility. I think, uh, yeah, I haven't been in touch directly with people up there recently, but um, I'm very confident that we could quickly establish some sort of a
I think
collaboration and
the fact
collective.
that we have one or potentially two receivers in the Antarctic, it would be nice to have one in the Arctic.
We were
Wait,
actually, yeah,
high Arctic.
we were actually talking about that in the telecon this afternoon with Yeoman. So
Yeah.
Well, we
Svalbard,
do we do have one, at Ellesmere Island.
yeah.
Right.
Oh yeah, but
Yes.
Yeah.
but a lot of these studies you don't just want one in the Arctic, you
Oh
want,
no, you want more? No, we absolutely
Yeah.
want more.
you
No.
know.
Well, the
Ultimately,
reason
we
it
want to get one up over at Baffin Island too. But
yeah,
yes,
Yeah.
Svalbard would be
the
a good
reason it
good site.
came Svalbard, there's a town there, and Nathaniel lived in that town for a little while.
Yeah. It's a very reasonable thing to I think try to do. So and I mean, Hyomin was also saying that he has more friends, down in Antarctica besides just, the U.S. stations in Neumayer, which and Rob was able to establish contact with. So Hyomin was suggesting that we try to, distribute these to all of our other friends down there too.
Yeah.
So
Yeah, he has the access to the Korean station.
yeah, Hyomin actually has a lot of active collaborations right now.
I think Gwen also has some contacts.
Hmm.
I recall him mentioning that.
That's proving difficult
Okay.
because of the administrative things with the Australian and British authorities.
What are the administrative things?
Oh, they just, I gather that they want all kinds of, formal proposals and, lots of paperwork and such that it's, Neumeier, was easy. Michael took care of everything.
Yeah.
And
Well,
Yeah.
the Korean station probably would be pretty easy. I was working with him on setting up some remote stations that were going down there. So
It
great.
may,
they're pretty
I mean,
straightforward. They're not so formal as the American system.
is I guess are Gwen's contacts with like the British Antarctic Survey and people like that?
Yes, yeah. There's a
Okay.
British and Australian. There's Jerry Butler, whose name's a UK physician, actually, who I think travels down there to, on his professional visits, has been trying to get some systems installed. But I think the last I heard was that he found it difficult. They weren't the authorities were not receptive. So.
Well, we might have other contacts in the British Antarctic Survey. I mean, I was just emailing the PI of the Super Darn radar at Falkland Islands, who's I think over at British Antarctic Survey last week. So,
Mm-hmm.
there might be an opportunity to through the space physics side of things.
Good. Well, that's,
Yes.
it's I think we've shown that it's pretty easy to do. I mean, and once they're set up, they seem to be, I don't know, so far we only have a week of operations. I can't.
Yeah.
But
Well, we have stations elsewhere that have gone longer than that. So
Right.
oh yeah, the stations up at Ellesmere is fine. The problems are the antennas go down.
Yeah.
We apparently lost the transmit antenna up at Ellesmere, and the receive antenna. The loop was, I think, never very effective, and now they've very difficult.
So that loop I sent you is not working?
It's hard to tell because they had a storm and I can't really log on to the site anymore. There's so many packet losses. The transmitter's down in town, okay, which still has good internet action, but the receiver is up at this atmospheric research station. It's about 10 kilometers outside of town, and it apparently has its own internet connectivity, which has become very fragile. So I've tried to log on to the server there and do a update of software update and failed. I guess I should try again now to see
Yeah.
if I can get access.
I would be very interested to know how that mag loop, because this is the one I sent you. I'd be very interested to know how that's working.
It's
Or
hard to it's hard to tell because but Pierre is going up there next month.
Okay.
And apparently, so we have an opportunity for him to go and do repairs and maintenance visit. So hopefully we'll be able to address all that. But I have to say it never worked terribly well. But I wouldn't necessarily blame that on the antenna.
Okay.
I don't know how it got installed. And
What are they using at Neumeier?
at Neumayer, they have some triangle. They're sitting on the ice on top of the ice, so they're 250 meters above the Earth.
Right.
So they've got a delta loop on the ground,
Okay.
which is feeding a series of receivers, and unfortunately, I think that they never really looked at the RFI environment very clearly because we could see all kinds of RF switcher lines across the spectrum. Now, fortunately, that if they don't land on a whisper band or on top of WWV, you're okay.
Right.
But and apparently in large part they don't. But I have to move on. I get these things set up, and I am not really looking at the results. So I'd like to, if you have someone who's interested in monitoring Antarctica and see what you can get from it, the data is available, and it's being uploaded, and you can remotely log on and tune to anything you want.
Can I get in there, Rob? I've been wanting to log in and tune around.
Yeah, you can
I
get.
always want to
Yeah.
know what the bands sound like for some weird location.
Yeah, sure. I'll send you a note. It's
All
just
right. Thank you.
another just like
Another
all the
port, I
other,
know.
just another port, another 2 digits you got to remember, or 3 digits you have to remember. That's yeah.
Yeah.
No, it's
I think I think to get someone serious to spend time looking at this data, I think we have to like write more proposals. And then you have to get them funded, which is, I don't know how that's going to go these days. But
Well, you can look wider with collaborations around the world.
yeah, and that's true. And sometimes we get lucky. Like I was really lucky. Shibaji, I guess has funding to look at do his study. So he's not funded through our proposal, but he's very interested in what we're doing, and it so happens that our data aligns well with whatever he is funded or needs to do. So we've been very lucky to get him. But yeah, but I think we'll keep trying to figure that out.
Well, I have to go, so I'm gonna
Yeah, and I do too.
say
This has been a good
73.
call.
Okay, good evening, everyone.
73, everyone.
okay.
Thank you.
Okay. Let's see. Well, we have any cleanup